Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we are going to learn and implement data structures and algorithms using Scala Functional Programming approach. In our previous videos, we had seen best time to buy and sell stock with at most one trade and with max possible trades. If you have missed on my previous videos, I will post a link on the description so you can take a quick recap. Alright, so now in this video we are going to address a new question, that is find the max possible profit for K trades, where the number of K or the number of trades will range from 1 to n because there can't be uh, more trades than the max possible trade that is available. Alright, so let's take a look what we had achieved till now. Alright, so this is the price list and this is the possible trade. So 1, 5, 2, 6, 3, 9. Like we see, these are the places where the uh, we are going to make profit when we are doing a buy and sell. Alright. Now to implement this, what we are going to do is we are going to divide this trade list into given groups for the K number of trade, and we will reduce each group, and any follow-up trade that left over from the reduce will be carry on to the next group, and similarly we will reduce each and every one and finally come up with the K number of trades. So let's implement the solution. So let's implement the group trades first, that is group trades. It is going to have the trade list, which is sequence of trade. Alright, it will have the value number of group, that is k int. It is going to return a grouped value, so it is going to be sequence of trade. Alright, now val first comma rest. Alright, so we are going to split the entire list into the k times the k groups. So it's going to be trade list dot split at, so it's going to be trade list dot length minus k minus 1. Alright, so let's create the group. So it's going to be first and then append rest dot grouped. Let's take a look how it looks like. So let's implement val test group. It's going to be group trades and we have trade list and comma k. So let's add this reverse here itself, so we don't have to add it everywhere again and again. Alright, so k is the value, let's take it as 2 and let's print the value of test group dot for each. Sorry, it can implement for as well, but let's make it quite readable. Dot for each println. Alright, let's see what it prints. So now we have to take in account the order in which the trade happens. We cannot jump the order, even though if we see there is a profit. So if there is an order, it has to go through the order itself. So 1 5 and 2 6 and 3 9 is the order. Now for group of 2, the one possible trade is if we merge this 1 5 and 2 4. So 1 6 and 3 9 is one possible way, 1 5 and 2 9 is the another possible way. So we will be implementing one solution as of now. Alright, so let's implement the reduce method. So it is going to be private dev reduce, and this is going to be reduce trade, which will reduce what? So it will reduce the trades, which will be sequence of trade. Alright, so it will have one accumulated value, which is basically the reduced trade, which will be having initially no trade or empty trade. Now we have a temp, that is again type of trade, which will also have no trade value as of now, and it is going to return again. First is the accumulated trade and next is the buffer that we are going to consider in our reduce. Alright, so as before, let's implement the pattern match on trade. It is going to be match the first case. When nothing is to compare, it will return, okay, it's case, and if there is nothing to compare, it will return AC comma temp. Alright, if we have something to compare, say T and rest. Alright, then let's get the value of buy and sell and profit out of it. T dot buy. Alright, so this is an extractor pattern that I'm using. This extractor pattern comes as inbuilt with the case class. When we will be discussing the design pattern, we will see or look more into this, how we can implement the extractor pattern onto any class that we see. Alright, so it is going to be sale T dot sell, and again it's going to be profit, so it is profit, which will be again T dot profit. Alright, now we have three values, that is AC comma, now the next value is the temp, that is the buffer, and the trade itself, which is coming in now. Alright, let's implement a pattern match onto it. So what are possible cases we can see? First case is that there is nothing, no beginning, no trade happened. So this is the first trade. It's going to be trade of none comma 0. Alright, let's copy this trade of none comma 0, because there is no reduce happened, there is no temporary buffer, but there is a new entry. Alright, let's give it, let's keep it unimplemented. Let's go for the next case. Next case would be again, so now we have a trade. So trade is, there is some buy and there is some sell and there is a profit, but there is no accumulated value and we have a trade that is coming in. Alright, now the third case, which is the most complicated one. So it is going to have all the possibilities, that is we have a trade that is sum of buy and we have sum of sell and we have a profit. Similarly, we have another trade which will be having sum of, say it is going to be temporary buy, then we are going to have sum of temporary sell, and then we are going to have some profit, and finally we are going to have the new record, a new trade coming in. So these are three possible cases that we are going to implement. Let's start implement one by one. Let's start implementing this. If this is the case, so it's going to just reduce left and reduce trade, and it is going to return the rest. It is going to add the new trade and it is going to have nothing as the buffer as of now. Now when it reaches here, so let's give a new line here for readability. Let's add this. Now here we have multiple scenarios. First scenario is the initial buy that is accumulated is less than the buy that we are seeing now in the new trade, and we have the initial sell which is greater than the sell that we see, the new cell. It means that we are good, we don't need to do anything, but we need to have add this as a buffer, we may need it later, so we add it to buffer and it is added to buffer. Alright, so this is the next case. Same thing, if we have buy is else if buy is less than buy, and we have as sale which is less than equal to sale. Alright, this is the case. So we have a buy, but we have a sale which is trailing behind. So now it is a time to make a new trade or expand the trade, or you can say the reduce the trade. So it is going to be rest, we are going to add a new trade. So buy is going to remain same, but all right, it is going to be sum of buy, comma, then we are going to add sum of sell, and the new profit is going to be sell minus buy. All right, so we have this, and whenever we are going doing this reduce, we will not have anything coming, as in we will clear in all the buffers. All right, so we have else if again. Now the buy has turned, so it is going to be greater than equal to the buy that we are going to see. Sorry, it's going to be equal to. Now again, same thing, the sell has also turned, so now we see there is a trend, so both of them are different, we cannot compare. So let's compare the price, the profit. So let's compare the profit. If the initial profit of the given accumulated value is higher than the new profit, it means we don't need to do any change. So what we can do is we will just call this reduce trade, and we add this rest, and it is going to be AC, and we are going to add it as T. All right, now the last possibility, if the profit, if this profit turns, so if this profit is not greater than the incoming profit, so we will just turn the case. So that case will turn as it will be rest, and it will be a new trade. All right, now let's go to the next possibility. Next possibility, this, watch closely, this has some work that we are going to see. All right, so what we are going to see, we have all possibilities here. First is like before, if we have initial accumulated buy which is less than the given buy that we have, and the sell s is greater than the sell, so it means there is no change in the accumulated value, we are going good, we are doing profit. But now the thing is, we have something called buffer. How we are going to handle this buffer? So either this buffer is going to stay as is, or it is going to update. Let's check on the conditions when it is going to update. If it is less than pi, same thing, and ts is greater than sell. All right, so it means that it is going good, so there is no change, so it is going to be reduced trade, it is going to be rest and AC, and then we are going to add this temp. There is no change because temp is coming as is, else if okay. So now again, if we have TB which is less than equal to buy, so we have the same case like we have seen before, and the TS, that is the sale, is now turned around, or we can say this if we are marking it less greater than equal to. All right, so now let's turn it around, so it make it it was greater than, now let's make it less than the actual cell that we see. So initially there was no change, so our initial value was either equal or it's greater than, so we are not going to make any change. But here now as we see that the sale is also on the other side and the buy is less, so it means that we can add this sale to our buffer. So let's make that thing happen, reduce trade, and it is going to be rest, and we are going to add the AC, and we are going to add a new trade. Basically we are going to upgrade the trade or reduce the trade here for the buffer. So it is going to be sum of TB as is, and then it is going to be sum of sell, and then we are going to write the profit, that is sell minus TB. All right, now the next case, else if. In this case again, now the profit has turned, so it is going to be greater than the buy. All right, and we have the sell, that is again it has also turned, so it is greater than the sell. So now the buy is also on higher side and sell is also on the higher side. So what we are going to do, we don't know that how much profitable this business will be, so we need to do, or we need to check with the profit and the TP. If it is greater than the profit, if it is greater than the profit that we see, all right, we have this TP, we need to make it as TP. All right, so if TP is greater than the profit that we see in that case, so what does it mean? So initially we have this temp that is going on, which is already on the higher side. There is no change, there is no point in making this change, so it is going good. Let's keep it as is. So now the value would be rest comma AC comma temp. There is no point. Now the last case in this category would be, again, if the profit turns, then it is going to be rest comma AC comma T. All right, first if is done. Now we go to the next else if. Again, likewise as we did here, b less than buy and b less than equal to sale. Similarly, we are going to implement something similar. B is less than buy and we have sale which is less than equal to sale. Now in this case, it is, we know that it is going well, so we will just do reduce trade and we are going to pass the trade, and it is going to be the trade is getting updated. It is going perfectly smooth, so we are going to add this new sale to the trade. We are making more profit. All right, so now it's going to be sum of sell and then sell minus b. So again we have done reduce, so we don't need to add, the buffer will clear itself. We don't need the buffer now. All right, so next condition, else if. Now the buy has turned. Buy is now if buy is greater than equal to the buy. All right, and the sale is greater than the sell, so it means that initial buy and sell is greater, but let's see what happens with the profit. So the profit is greater than the initial profit that we have, so we don't need to make any change. If we make this change, we will, as we have seen, there are two possible outcomes that we see. So if we play with this condition, we will get the other outcome. So we can expand this solution further, but as of now we will stick to this. Now there are multiple possibilities. In this case, we know that there is no change in the initial value that we are going to add, that is the reduced value, but there could be a change in the temporary buffer. So let's see if we are going to make any change. So TB, and it is going to be less than pi, and the TS, which is going to be greater than cell. So it means that we have a value where it is going perfectly fine with the new incoming trade. Already temp is making better, so let's keep it as is. So it's going to be rest comma AC comma temp. There is no change. Next condition, else if in this. Now again, TB is less than pi, but now your sale has turned. So now the sale has turned, so it will be TS and less than equal to sale. All right, so now we see that we have a sale that is making better. So now it's time to swap the or expand the trade. So it's going to be reduce trade, rest comma AC comma new trade. So it's going to be sum of TB comma, we are going to add some sell and then add a new profit. So it's going to be sell minus TB. All right, so we are making a profit here and clearing out any temp that we have. Else if next condition here again. So if your TB is less than pi, all right, so if your TB is less than pi, or say greater than pi, and your TS is greater than sell, and you are making a profit, your TS is making a profit. All right, in this case Here it is, and sorry. Alright, your TP, it is the TP is making a profit greater than the profit. Alright, so it means that you are going perfectly fine. There is no need to make any change. So it is going to be rest comma AC comma temp, and the last condition, if the profit turns, so does the trade. So it's going to be rest comma AC comma T. Alright, and finally we are almost there, the last else condition. So else, if nothing suits, it's going to be a new trade itself. So it is going to be rest comma T. Alright, so we have implemented our trade. Now let's conclude this. So yes, this closes this. Okay, now just alright, so this is the method, I think so. Yes. Alright, now we have included this till now we have created this reduce. Now we have to use this reduce to calculate the max profit. Alright, so let's create the method, that is, let's make it private dev get max profit with k trades. It will take the trades as the sequence of trade comma the value k as int, which will return the sequence of trade. All right, here first condition, if the k is greater than equal to the trades dot length, then we are just going to return the trade because it is too long, and it is going to be always the max trade. Let's make it trade. All right, now it looks better. Now the else condition, here first is we are going to call the groups of trade. So it is going to be group trade where we had this trades list. So let's see if this is the one which we are looking out for. Max profit, yes, trades list. All right, this is perfect, and then we are going to call this k. So now we are going to run fold left on this to conclude. So it's going to be grps trade dot fold left. This fold left is going to return two values because we are going to run this on our reduce. So it is going to return first the sequence of trade, which is basically the final trade of for k number of times. All right, and let's implement the method. It's going to be trades tuple would be, yeah, nice, comma trd, that is the trade. All right, let's implement this method now. Well, this is trades comma temp trade. It will be again, so all right, now we have this. Now we get the results comma temp, which will be calling it recursively. So now if the, because we have to pass this temporary buffer, so temp trd. All right, so if temp trd is equal to no trade, then you just call the reduce on trd, and else just call the reduce trade on. We have to append the value, so temp trd will be prepended, so it is going to be like this, and trd. All right, so it is prepended now, so it is going to return sequence of object. Perfect. So now, so what we have, this trade. All right, so this has to be an object, a value. Now it is going to return something which will make more sense, that is trades, and then we will append the result, and we are going to return the temp. All right, so now this is a tuple, but we are interested in the first value only. So this implements the entire value for the max k trades, or the max profit for k trades. So let's calculate the max profit k trades is equal to get max profit. All right, so we are going to pass this trades list. Basically we are getting this trades list, so it should be the trade, basically what we are going to pass here. So let's make it trades list, comma, we want to do it twice, and let's print it out, max profit k trade for each println. All right, let's run this, and before that let's add some beauty to this. Okay, let's run this. So now we are going to see and also differentiate between what we are going to get at the end. Okay, so the first profit, it is booked at 1 6, and second is 3 and 9. As we see, it's 11. So no matter what, how you do, it's going to be 11. Now, like I said, it implements one solution, but if you make the changes in the given if and else, it will give you the another condition as well, another output as well. So this concludes the overall implementation of best time to buy and sell stock with k number of trades. If you enjoyed this video, please like and subscribe, and see you in the next video. Thank you.